Hi, this is Mr. Bledsoe, and in this video we're going to talk about function notation, which is this notation that looks like this, an f and an x in parentheses, read f of x. And so let's say we have a function that we write like this, y equals x plus 9. It's a fairly simple function. And if I wanted to, I could make a table of values for this function. Let's say I'm going to have some x values, let's say -1, 0, 1, and 2. And if I want to find the y values that are associated with each one of these x values, then I would just take -1 and I'd substitute it here for x, and y would then be equal to -1 plus 9, which is 8. And I can do the same thing with the rest of these values here. If I put 0 in for x, then I get y equals 9. If I put 1 in for x, then I get y equals 10. And if I put 2 in for x, then I get 2 plus 9, which is 11. And so I can see that each of my inputs, each input maps to exactly one output. And so I know that this is a function. And in fact, sometimes we would say y is a function of x, which is just another way of saying y depends on x, or the value of y depends on what the value of x is. Well, I can also, using this same function, I can write this function, instead of writing it as y equals x plus 9, I can write it using function notation. F of x equals x plus 9. Now notice this second way here of writing this function, it's exactly the same. I'm just writing it using this different notation, this f of x notation or function notation. But I'm doing exactly the same thing. In fact, if I make my table of values, instead of writing a table of values with x and y, I would write my table of values with x and f of x, and let's say I use these same values, -1, 0, 1, and 2. Now, if I take each one of these x values, notice what I'm going to do. I want to know what's the value of f of x when x equals, say, -1, my first value here. Well, using function notation, I can actually write this in a particular way. This is one of the things that makes function notation useful. If I want to know the value of the function when x is equal to -1, I can write it like this. F of -1. Notice I just took my value for -1 here, and I just plugged it in right here where the x goes. So I have f of -1 equals, again, I'm taking my -1 value, I'm plugging it in for x. So let me plug that in right here. It equals -1 plus 9. And that gives me 8, which is what I had before. All right, so all I'm doing is I'm just substituting this value of x here I'm substituting the value -1 in everywhere I have an x. And I would read this as f of -1 equals -1 plus 9 equals 8. So f of -1 equals 8. And I can do this exact same thing with all of the rest of my values here. F of 0, if I want to know what f of 0 is, well, f of 0, I just substitute 0 in for x. F of 0 is 0 plus 9, which is 9. And there's my value 9. F of 1 equals 1 plus 9, which is 10. Oops. F of 2 equals 2 plus 9, which is 11. All right. Same values as I got before, it's just now I'm using function notation. And now here's kind of the important thing here. And this is the point of confusion for a lot of people. Notice that this function notation, f of x, it kind of looks like multiplication. And a lot of students think, oh, well, there's an f and then there's the parentheses there with an x. That must mean f times x, as though the letter f stood for some variable the way that the letter x stands for variable. But this is not correct. F of x does not mean f times x. We're not doing multiplication. Function notation does not mean multiplication. What it means, as we've just seen, is it means substitution. Substitution. In other words, whatever value I want to know, whatever value of x I'm going to use, I substitute that value in using my function notation. So if I had a different function, let's say I had a function, my function was f of x equals 3x minus 2. Well, if I want to know what is f of, let's say, I don't know, f of 5, I'm going to substitute the value 5 in for x. So I would write f of x equals, or rather f of 5 equals 3 times 5 minus 2, which is 15 minus 2, which is 13. So f of 5 would be 13 for this particular function. And that's all function notation is. It just means you're substituting values, but it does not mean multiplication.